This is part 2 of the videos for lesson 9.2, Solving Systems of Linear Equations by Elimination. This video will show you how to solve examples 3 and 4 from the notes package. And there will be one more shorter video that will show you the solutions to examples 5 and the key ideas. Just a reminder to refer back to the steps for how to solve a system of linear equations using elimination when you're doing your practice questions and/or the examples. Alright, in example 3, we notice that in order to be able to do step 1, which is line up the equations so that the like terms are in the same columns, we are going to need to rearrange one or both of the equations to get in the same form. Now, I do want to have the form of ax plus by is equal to c. So I need to move the 6 in the first equation to the left side, or the right side, sorry, and I need to move the 5x to the left side of the second equation. In order to do that, you are going to have to subtract 6 from both sides of the first equation, and that will give you 3x plus 2y is equal to negative 6. In the second equation, you're going to have to subtract 5x from both sides, and because we want the x term written first, we need to go negative 5x plus 7y is equal to 41. So now that we have our equations so that the columns are lined up with like terms, we can go ahead and identify the variable that we want to eliminate. We see that our x terms have a negative 5 and a 3, so not the same numbers, and our y's have a 2 and a 7 in front of them, so also not the same coefficients. So we need to get these equations to have the same coefficients by multiplying the equations, one or both of them, by a constant to get the same coefficients in front of one of the variables. So this is actually considered step 2, if we referred back to our steps, is choosing and making sure we can eliminate a variable. If you can't eliminate by adding or subtracting, we're going to have to multiply like this. So we're going to put our equation in brackets, both of them, and I'm going to pick just the x variable that I want to eliminate. So I look at the numbers in front. I don't have to worry about the negative for now. And I want to have the lowest common multiple of 5 and 3, which is 15. So I want my new x terms to be 15x. I'm going to have to multiply the first equation by 5 in order to get a 15x in the top equation, because 5 times 3x is 15x. But I also have to use the distributive property here, so I have to multiply every term inside the brackets by 5. For the second equation, I want to get 15, so I'm going to have to multiply by 3. And again, don't worry about the negative yet. We can have negative 15, that's okay. So I multiply every term in the brackets of the second equation by 3 in order to do that. I'm going to put an equal sign here, and I'm going to write my new equations just below. So for the first one, 5 times 3x is 15x, 5 times 2y is plus 10y, and it's equal to 5 times negative 6, which is negative 30. For the second equation, negative 5 times 3 is negative 15x, and 3 times 7y is positive 21y, and 3 times 41 is 123. So now we have opposite numbers in front of the x, so we will be able to eliminate it. If we put the second, so now we're at step 3, sorry, put the second equation in brackets, and we have to decide if we're going to add or subtract. When you have opposite signs in your equations, you are going to add them, and then that will work out to 0x. 15x plus negative 15x is 0x, and so we don't actually need to write that, we just need to know that it equals 0. And we go ahead and add the rest of the columns together. 10y plus 21y is 31y. The equal sign just carries down. Negative 30 plus 123 is 93. All right, so for step 4, is where we're at. We need to solve for the remaining variable. We have y left, so to get y by itself, we're just going to divide both sides by 31, and we will get y is equal to 3. All right, now on to step 5. So these are pretty quick steps. Step 5, if you want to refer back to the steps, that's what they are. Step 5, we need to solve for the other variable. So we pick any of the equations from the beginning, and we're going to solve for x. I'm going to choose the second one. Why not? 7y equals 5x plus 41. Okay, so now we sub in y equals 3, so we got 7 times 3 equals 5x plus 41. And 7 times 3 is 21. 5x plus 41. And I'm going to subtract 41 from both sides. 21 minus 41 is equal to negative 20. So negative 20 equals 5x. I'm just going to go over to the right here and finish my solution. And lastly, to get x by itself, we need to divide both sides by 5. So x is going to equal negative 4. And then we can state our solution is the point negative 4, comma 3. And if you were to graph these two equations, you should get negative 4, comma 3 as the point of intersection. I just want to point out as well that we didn't have to choose the x terms to get the same coefficient in front of them to eliminate the x term. We could have also chosen to eliminate the y terms, and then you would have been left with the x to solve for in step 4. If you would have done that, you would have had the equations and had to pick different numbers to multiply by. So I've just rewrote the equations over here, and if I had chosen the y terms to eliminate, the lowest common multiple between 7 and 2 is 14. So to get the y term to have a coefficient of 14 in the first equation, I would have to multiply the equation by 7. And then, in order to get a coefficient of 14 in the second equation, I would have had to multiply by 2. So you don't have to choose the x every time to eliminate. You could also have picked the y, and it would eventually still work out to the same answer. In example 4, the word problem, we want to set up two equations that we can solve by elimination. Now, we have a group of people buying tickets for University of Alberta basketball playoff game. 2 student tickets and 6 adult tickets cost $102. 8 student tickets and 3 adult tickets cost $114. What was the price for a single adult ticket, and what was the price for a single student ticket? This gives us a clue as to what our variables should represent. So I have chosen x to represent the price of an adult ticket and y to represent the price of a student ticket. And now we can go ahead and write our equations that we can use to represent this situation. And we get that out of the other 2 sentences in the question. 2 student tickets and 6 adult tickets cost $102. So that's one of the scenarios they give us. So if we have 2 student tickets, the total cost for those would be 2 times the cost of a student ticket, which was y. And we're adding the cost of the adult tickets, which there was 6 of them. So 6 times the cost of one adult ticket would give you the total cost of the adult tickets. And then when you add the student tickets to the adult tickets, the final cost was $102. So that's the first scenario they give us. The second scenario is 8 student tickets and 3 adult tickets cost $114. So we go and we say 8 times the number of student tickets plus 3 times the number of adult tickets will give us a total of $114. So now we have our 2 equations, and we can go ahead and solve those. And I don't have any similar coefficients, but if I look at this 3x here, if I just multiply the bottom equation by 2, then that would give me 6x in that middle term. So I don't have to multiply the first equation by anything. However, I could, instead of eliminating the x's, I could eliminate the y's instead. So if I wanted to do this differently, instead of multiplying the bottom equation by 2, I wouldn't have to multiply it by anything, and I would multiply the top equation by 4, which would give me an 8y on the top equation, and I already have 8y on the bottom equation. So if we just continue with eliminating the x's, okay, the y's is just a different way to do it, I would have 2y plus 6x equals 102. That stays the same because I didn't have to touch it. And then 2 times 8y is 16y. 2 times 3x is plus 6x. And 2 times 114 is 228. Now I can go ahead and put my second equation in brackets. And to eliminate the x variables, I'm going to have to subtract. So remember, you decide if you add or subtract. But we have to make sure we get 0 of one of the variables. So 2y minus 16y is negative 14y, and 6x minus 6x is 0, x. And so 102 minus 228 is negative 126. I'm just going to rewrite that up over here on the right. So I have negative 14y is equal to negative 126. To get y by itself, I'm going to divide both sides by negative 14. That will give me y is equal to positive 9. So if we look back at what our y represented, that means that the price of a single student ticket is $9. So now we just have to go and solve for our x value. And I'm going to use the first equation from the set of equations, 2y plus 6x equals 102. I'm going to sub in 9 for y. You could use the second equation too, doesn't matter. And 2 times 9 is 18, so we got 18 plus 6x equals 102, minus 18 from both sides, and you get 6x is equal to 84. And lastly, divide both sides by 6, and you get x is equal to 14. And the x was the price of the adult tickets. So we have $14 for an adult ticket and $9 for a student ticket. Please go and check out the next video for example 5 and the key ideas.